Rahim. Guys, once again Mr. Atik is here from the science department and we will solve, this is Wednesday, we will solve or we will continue the section 2 of chapter 14 revision sheet solutions. Okay, we solved section 2 until the 5th option. Now we will start from the 6th one and some descriptive question at the end we will solve. Okay, so let's proceed. The 6th look at which stage of ionization of H3PO4 produces the most ions in solution. A. H3PO4 aqueous plus H2O liquid. Look at reversible reaction. Okay, H3O aqueous plus H2PO4 aqueous. This is the correct option. Most ions, they produce the most ions, by the way. Now the rest of them are just quite different from these things, or all stages produces the same number of ions in solutions. No, this is absolutely not. Must be different. How come? Now the 7th option, which of the following can act as a Lewis acid? So Ag, silver. Okay, Ag plus, we call them aqueous silver. This is chlorine, this is NH3, and this is Be4, barium fluoride. Okay. 8. A Lewis acid A is an anion. No, how come? Donates an electron. No. To form a covalent bond. No. Can be a substance that does not contain a hydrogen atom. Yes, acid. All of the above. No. Now look at the 9th option. Which of the following substances can act as an Arrhenius base, a Bronsted-Lowry base, and a Lewis base? If negative, H plus, B, NH3, D, NaOH. So this is NH3 base. Okay, Lewis base. So this is NH3 aqueous. Which of the following will be present in an aqueous solutions of H2SO4? Make it like this. Make it like this. Here, use to arrange. So the A option is H3O plus, HSO4 like sulfates, has this sulfates as well with -2, and all of the above. So all of the above. Okay, aqueous solution of sulfuric acid. Now let's proceed towards the next short answers, which are quite important for you guys. Short answers in the following questions in the space provided. Look at first A option says what? Write two equations that shows the two-stage ionization of sulfurous acid in water. Stage 1, H2SO4, H2SO3, then H2O yields toward H3O and yields toward HSO3 aqueous. Stage 2, HSO4, HSO3, then H plus H2O liquid yields towards what? These two means what? Yields. Okay, H3O and SO3. The first answer. Okay, two ionization states. Ionized, they become ionized. Which states? Which stage of ionization usually produce more ions? Explain your answers. What do you think? Stage 1. Okay, it will produce what? More ionization or produce more ions. Okay, stage 1. Now for the second A option, define Lewis base. Can OH function as a Lewis base? Explain your answer. Look at the answer is a Lewis acid. A Lewis base is a species that donates an electron pair to form a covalent bond. Yes, OH. Yes, OH is a Lewis base. There are two non-bonding electrons pair available for it to donate. For example, OH, then Al aluminium yields towards AlOH whole 4. Got the idea? So Lewis base is what? That donates electron pair to form covalent bond. Okay, for the A option. Now for the B option, we have defined Lewis acid. Now can H plus function as a Lewis acid? Explain your answer. Yes, of course. Look at A. A Lewis acid is a species that accept an electron pair into a vacant orbital to form a covalent bond. H is a Lewis acid. Its first orbital is vacant and an electron pair from a base can fill it. For example, H, then aqueous, then OH yields towards H2O. When they combine, they form what? H2O liquid. So this is what? A species that accept an electron pair. We call them what? Lewis acid. Question 3 says what? Identify the Bronsted-Lowry acids and Bronsted-Lowry base. Look at acid and base according to the Bronsted. Look at, we studied, by the way, Lewis, okay, then Bronsted, Lewis, then Arrhenius. Understand? So these are the guys who researched over these things. Okay, on the reactants side of each of the following equations for reactions that occurs in aqueous solutions. Explain your answers. A, H2O liquid plus HNO3 that yields towards H3O plus NO3 negative. Okay, A option says what? HNO3 is the Bronsted-Lowry acid because it donates a proton to the H2O. The H2O is the Bronsted-Lowry base because it is the proton acceptor. It is the proton acceptor. B option says what? HF plus HS yields towards H2S, hydrogen sulfide gas, plus fluorine negative. HF is the Bronsted-Lowry acids because it donates a proton to the HS, hydrogen sulfide. The HS negative is the Bronsted-Lowry base because it is a proton acceptor. Got the idea? Study it, research it, you will find good way of answers. Okay, by the way, these are not that much conceptual one, so easy because it relates to all the definitions. Okay, let me organize this thing for you guys. Can I remove this one in shape of this? Yields. Look, got the idea? Now this is what? The stage 1. Let me make it bold for you guys or underline so you will get a clear idea. That's it, stage 1. Okay, Now for the answers, this one, a second, make it clarify. Just remember, these are all definitions, okay, that we study. Yeah, it will be so easy for you guys now to concentrate and to, you can say, like yeah, study it. These are all the simplest definitions that we studied before. Remember, okay, we studied only few conceptual definitions there, okay, according to the Arrhenius, Bronsted, Lurie and Lewis. Okay, so this was today's lecture, like the Wednesday one.